Okay, I was a bit late. Let's see. So we can just greedily subtract the smallest element because that's like the best thing we can do. And we want like the number of rounds if operations. A bit hangover. Hope I wouldn't be too slow. Actually, what does it mean? Okay. Greedy again. So we have to match the next group's sum of grades and also like the number of people to be at least the same as the previous group, and we do that greedily. Like we always put the smallest amount of people possible in the current group. Current grade sum. Current people equals 0. Wait. Oh, okay, it's not that simple because wait. Why couldn't we divide this into two groups? Ah, okay. Let me think. I thought like it meant that the last group doesn't count in the sense that it didn't have to be greater than or equal to the previous group, but apparently it's not the case. Seems a bit tricky. Let me look at the next one first. Suppose one outgoing edge. V node such that the maximum between okay, we just do two breadth first search while taking care of cycles. Like by breadth first search, this means like traversing the linked list. D1 is like distance from node 1. D2 is like distance from node 2. And I define the helper function so that I don't have to write it twice. Let's see. Source and lookup so that I can pass the dictionary reference in. Fill lookup with distance from source. Am I missing something? Seems easier than the previous one. No, I didn't look up. Or let me name it D. And this like this so that I don't mess up. Okay, the first round is okay, and then we need to take care of this special case where edges, like there's no outgoing edge. That looks okay. And we want to return the node with the smallest distance. And what is it? How do I iterate through the union of two dictionaries? I forgot again. This stands for minimal distance. So do I have in? What if there's no, okay, if no possible answer exists, we return -1. No, doesn't make any sense. Not too clear-minded now, so I'll just see what I can do. Two plus if there's a tie, we break tie by smallest index. Okay. Alright, I give up. I'll just do another thing. Minimizes the max. I don't need so many parentheses. Or do I? I want to put a default. I forgot what, if this is running Python 3.10. Okay, there will be something, otherwise, like, because we always have this ifs, so it's okay. It's first ranked by distance and then by index, and we take the first one. I have no idea what I am doing. Okay. Wait, what? Oh. Two and two. Great. Graph again. What's going on? What? Like, if we don't want memory efficient algorithms, this should be pretty trivial. But what about this? I'm sort of stuck on this. So we can keep like a remaining thing and make sure that our current one doesn't exceed the remaining thing. C grades stands for current grades. Okay, CPP, whatever, stands for current people. Let's put 1 because we have like the largest group in the tail. I also need like previous, okay, this is like previous grades and previous people. Too many variables to keep track of. So the general strategy is to like really like adding as few, like as little people to the group as possible while not like exceeding the last group. If we do, then we return the answer. Else we can like make previous grades and previous people equals current grades and current people, and answer plus equals 1. And here what we're doing is sorry, I'm not explaining too much today because my brain isn't really working. Grades. I reverse it so that I can pop from it. It's like easier to write this way. True. While grades and I can put this -1 because in the beginning we only need like anything for it to hold. Or I need at least one thing for it to hold. So I still need like 0 here. Smaller than or equal to p3s n. How did I get 6? Okay. Or maybe I write this first. So if the current group is not greater than or equal to the remaining group, we move to the next round, which means we're reassigning current grades, and it's okay because it gets assigned to 0 here. While grades, and I'm just wondering where the deadlock, like where does the infinite loop happen? So we're adding this, it's okay. This gets signed here. Oh, I forgot to subtract the remaining thing. And what was the last modification that I did? Does this fix it? 2, 1. Okay, interesting. Ah, okay, I can reorder this. I don't have to. What's my problem? I read it completely wrong. So, does it make sense to first sort it? Raise reverse equals true, because do we want to put the larger ones later or not? I don't know what's going on. So there must be some bug in the code, because in either case the second condition should make it such that like the answer does not exceed 3. So what's wrong? If we popped everything, then we can return answer +1, right? Like, it shouldn't go to this branch, because like this should hold, because that's like what we were trying to do. No, like in the last round. No, it doesn't go here. I'm gonna write the graph one first. So this one finds a loop, like a cycle. What am I trying to do? So if it doesn't go anywhere at some point, then it's not a cycle. We can just return. Otherwise, we need to check, like, when we get out of this loop, that means we found a cycle, and we can check, like, the difference between the current t and the previous t. Let's put -1. And I need a non-local answer here. Apparently it's wrong, but I can print B to see what's going on. Why is it always 0? I thought I was incrementing. Or should I start with 1, 2, 4, 3? So like when I go to 2, yeah, I forgot to move to the next step. Three minus 1, great. One, two, three, or I. Where did I get the 2 from? Interesting, I don't even have a 2 in the... Zero, 1, 2, 3, 4. 4 plus 2. Okay. So, let's see why I did wrong. Like, just because we're going to something we've seen before doesn't mean that it's a cycle. It has to be something that, like, we're seeing on the current round. So maybe, like, I need a different D each time. If it's in some previously visited thing that's not in D, that means we've computed the cycle already. Does that work? Nice one. Great. Okay, now we're back to this greedy thing that I was stuck on. Order group such that so we're popping from the smallest to the largest. And we need to keep track of like when we just cannot form another group because the remaining people don't have enough grades added up together. That's what these variables do. And we also keep track of previous group in like grade because the current group need to get larger than the previous one. And the answer is 1, which is like the last largest group. And while true, we first assign like this current group to default like 0. And when we still have people to add, and the current grade is not as is not larger than the previous grade and current people is not larger than previous people, we add the next grade to the current grade. We subtract the current next grade from the remaining grade. We add 1 to current people count. We subtract 1 from the remaining people count. And like when we get out of this while loop, there are 2 cases. Either we run out of people or we are better than the previous group already, so we can move forward. But if we're like, the way we get larger than the previous group is by making the last group smaller, then it means we can only form 1 more group on top of that, which is like answer because the 2 groups merged together and we started out like having 1 group. Otherwise, that means we can move forward. Moving forward means like the previous grades and people get assigned to like current grades and people, and we add 1 to answer. That looks perfectly okay. I don't know why that works. Why that doesn't work. Because this should be an or term. And what about this? Grades and that's so embarrassing. Oh my god, that is so embarrassing. It's funny. Oh my god. Could have done a lot better. Okay, thank you.